For this question, we're asked which of the following is true for the depletion region capacitance of a PN junction. Now, into the notes linked below the like button on about page 45, we have depletion region capacitance, and below this, we have diffusion capacitance, which is our forward bias. But for this one, we're going to be looking at the depletion region capacitance, and that's going to be these notes right here. So the first question says the capacitant depends on the cubed root, so that is like 3 square root, so it's cube root, of the reversed bias for an abrupt step function. So when we look at our abrupt step function, there's not many notes about this inside of here. And so this is just told this is false right here. A is false. Next we have the amount of charge stored decreases as the reverse bias increases. We can clearly see this. So from our graph, we have our bias point right here. And so after this, our reverse bias would obviously be decreasing, and more to the right would be increasing. So the amount of charge stored is this Cj, this slope. And that is the charge stored in the depletion layer. And so we can see that it's increasing. It's slowly going up. Not going up as fast, but it is still slowly going up. And since it's slowly going up, that means the amount of charge stored is not decreasing. So this one is false. And so is A. So this one is false, this is false. Right here, all of this we have an error with. And right here, the only part that we have an error with is right here, which is correlating to right here. Now if the reverse bias was decreasing, the amount of charge stored would be decreasing as well. They're related to each other. Next we have the capacitance depends on the square root of the reverse bias for a linearly graded junction. And when we look at this, we do not have a square root for our reverse bias with any of our function for the junction inside of here. This is false. So obviously it's not all of these. Lastly, we have the capacitance decreases as the reverse bias increases. Well, our capacitance is this Cj right here, not the Cj naught. And if our reverse bias, which is this part inside of here, is increasing, that means the capacitor is going to get smaller. If the bottom part is increasing, the capacitance is overall going to get smaller because we have a small number divided by a larger number. And so that would be decreasing, and this would be true for this question.